We're going to go ahead and get started. Thank you all for finding your seats. I hope you've had a chance to get some food and some coffee. There's plenty of both, so please feel free to excuse yourself to grab a little refill at any time. My name is Jennifer Smith. I work for the USDA California Climate Hub as a program manager and am generally focused on how climate change is impacting our forests' health, and wildfires often go hand in hand with that. So I'm here today as the MC for this event, and I'm really, truly delighted to have the opportunity to learn more about the work you all are doing. I think probably goes without saying, especially to this crowd, that water is an underlying connection to any sector, any system that we work in. So I'm delighted to have the opportunity to learn more. And I briefly want to acknowledge that if you've ever planned an event or been involved in it, you know how much time and effort it takes to pull anything like this off. So I want to recognize some of the key organizers for today, which included, of course, Dr. Isaya Kisekka, Felix, who's in the back still organizing stuff, waving, yes, thank you, Felix, as well as Charlie, Sangita, and also my colleagues from the California Climate Hub, Lauren and Steve Estoya here. We'll all be floating around today, helping make things run smoothly. If you have any questions, feel free to come to me directly or any of the folks I tried to just point out. We also have a really fantastic crew of volunteers, of students who are helping pull all of this together, so we're quite fortunate in that way. A couple of brief but important logistics. Most important without a doubt, if you have not found them yet, the restrooms are across the lobby. So just instead of coming to this side of the lobby as you walk in, go to the other side, and the restrooms are right there down the hall. Secondly, you may have noticed that our agenda is jam-packed, and many of you have traveled here today to be with us. All of you have set aside your time and given that to us to be able to participate here with your colleagues. So part of my role is to deliver on the promised opportunity we've given you to have all these opportunities to hear and share and connect with your peers. And what's going to be crucial to that is being pretty disciplined about our time management. So for speakers, I'll be sitting right here in front of you. You've been communicated about this, I think, in emails, but you'll see me holding up a 2-minute warning sign, a 1 minute, and then a stop. So do your best to abide by that so that we have time to hear from everybody. So with those reminders out of the way, we're going to keep rolling, and I'm going to hand it over to Dr. Isaya Kisekka. Isaya is the director of the UC Davis Agricultural Water Center of Excellence and an associate professor of agrohydrology and water management. And in these roles, he leads research efforts on enhancing sustainable water management and use in agroecosystems.
Thanks, Jennifer, for the kind introduction, and I'm really happy to see all of you this morning. I want to give a brief overview about the project. This is a funded project by the USDA, National Institute of Food and Agriculture, and our long title is Sustaining Groundwater and Irrigated Agriculture in the Southwestern United States Under a Changing Climate. That's a mouthful, but a short version is the Southwest Groundwater SAS. The SAS is a NIFA program that stands for Sustainable Agricultural Systems. Probably some of you have seen this map. This is a map of the United States showing depleted groundwater aquifers that we have in the country. And as you can see, most of them have experienced drawdown ranging from 50 to 400 feet. That is significant, and it is unsustainable. Some of the major ones are the Ogallala High Plains Aquifer in the middle of the country that covers over 8 states. And another one is the Central Valley Aquifer System. All these aquifer systems are very important agricultural regions, but we cannot continue to use them in an unsustainable way. Other aquifers include the Arizona alluvial aquifer systems. And the question, though, is, how do we get here? We get here by pumping more water than the rate at which these aquifers recharge through precipitation or recharge from stream flows. So how do we proceed? the next map that I want to show you is this, that looks at 20 years of changes in irrigated agriculture in the US. Each red dot on this map shows a decrease of 1,000 acres in irrigated agriculture in a given region, and the blue dot shows an increase of 1,000 acres of irrigated agriculture in a given region of the US. You'll notice that California has lost a significant amount of irrigated agriculture, as well as Arizona and many parts of the western United States. And this map, actually, if you overlay it with a map of groundwater depletion, they sit over each other very well. So as a country, as society, how do we proceed? We need to keep our aquifers in a sustainable state, but we also need to produce food. And our food systems are largely dependent on irrigated agriculture. If you look at this chart, the dark colored bars show the proportion of irrigated land, the proportion of agriculture that is irrigated, which is only less than 20%. And the light bars show the contribution of irrigated agriculture. While we practice agriculture on less than 20%, irrigated agriculture on less than 20% of all agricultural land, its contribution is 50% or more in some years. So the 80%, which is rain-fed, that is non-irrigated, only contributes 50%. So our food system cannot survive without irrigated agriculture. At the same time, we cannot continue to pump our groundwater aquifers in an unsustainable way. So how can we reconcile these two things?
Sorry to interrupt you. You can't get the audio, so you need to speak into the mic or use the tag.
Okay. Okay, my audio wasn't getting into the camera, but I think it's okay now, or I'll switch to a different mic. Okay, so to address this problem, as a project, we came up with a vision statement. And our vision statement is to alleviate groundwater overdraft. We don't want communities that depend on groundwater as their source of drinking water to have dry wells, or farmers that depend on irrigated agriculture all of a sudden to run out of water. The next thing that we're addressing is non-point source groundwater contamination. A lot of it is attributed to agriculture. How do we develop farming practices that are protective of groundwater quality? The next one is there are many communities in these irrigated agricultural regions that depend on irrigated agriculture. So while we're trying to make sure we're managing our groundwater sustainably, we also have to be mindful of the socioeconomic impacts of these communities that depend on irrigated agriculture. So how do we get there? We propose to use ecosystem practices, work with nature, not against nature, as well as leverage technologies. Lots of new technologies that can allow farmers to be more efficient in the way they use water for agriculture. We have four objectives. The first one is related to sustainable agriculture systems. The second one is on developing models and decision support tools for groundwater management. The third objective is on socioeconomics of irrigated agriculture, and the last objective is on education and extension activities. We were funded up to $10 million from USDA, National Institute of Food and Agriculture, and as part of this funding, they also designated us as a center of excellence in agricultural water. These large projects, they are required by Congress to be integrated, meaning they have to have research, education, and extension. Now, in the next slides, I'm going to quickly go over what we are doing as a project and show you some faces of the people that are working on different aspects of the project. So if you see them in the audience or in the hallways, you can discuss with them more details. So in terms of research, we're focusing on groundwater, sustainable ag systems, and socioeconomics. And Under sustainable ag systems, we have climate change and vulnerability risk assessments that are headed by my colleague Steve Ostoja from the California Climate Hub. Other team members are Lauren Parker and Ning Zhang. We also have a soil health team that is headed by Christina Lascano and my other colleagues, Amelie Goudan, Melika Noko, Helen Dalkey, Kosanas of Karev, John Idaho, and Dibanka Sanjal. I have to mention that this is a multi-state project with investigators from California, University of California, Davis, University of California, Berkeley, Stanford, and California State University, Fresno, as well as University of Arizona and New Mexico State University. Another aspect of the project is on desalination of brackish groundwater. We have quite a bit of brackish groundwater that we can use in agriculture, but it has high level of salinity. How can we desalinate it and put it to beneficial use? So we have a team working on that, led by Carl Longley, Pai Zhu, Hio Wang, and Sanka Banerjee. The water management team includes myself, Andre Dakach, Kelly Thorpe, and Matt Ruby. I mentioned the universities, but we are also collaborating with USDA ARS labs here in Davis and in Maricopa. And we're also working on nutrient and salinity management, and that work is being done by my colleagues, Patrick Brown and Sharon Bennis. We also have a groundwater team led by my colleague Thomas Hatter. Other colleagues are Scott Bradford, Rosemary Knight, Sharon Megdal, Helen Dalkey, Serge Green, Manoj Shukra, and Melika Noko. Socioeconomics, we can look at the physical sciences, but also the social sciences of groundwater management and sustainable ag systems are very important. And that work is led by Katrina Jesue and Mark Robel, Taylor Scott, and David Zilberman. As I mentioned, these are integrated projects which need to have education as well as extension. So under education, we're looking at post-secondary education, K through 12 education, and informal work development, educating the entire society about the importance of groundwater and irrigated agriculture. This is not just a US problem, this is actually a global problem. And that work is led by a strong education team, led by Manoj Shukra, Shannon Norris, Charles Hillier, Walter Mizano, and Dr. Wright from Fresno State. We have a very strong team of postdocs and grad students that meet regularly to support each other. And our extension team that's looking at different aspects of extension from the traditional land-grant extension system to private industry and different levels of government is led by Melika Noko, Frank McPherson, Marian Bird, Barrell Johnson, and all these team members are in the audience this morning. So if you want to learn more about these different aspects of these projects, please feel free to chat with them. This is a map of our study sites. We're working in California predominantly in the Central Valley. In Arizona, we are working in Central Arizona. And in New Mexico, we are working in the Lower Rio Grande. If I'm to summarize the project on one slide, this is the slide that will summarize it. We are looking at the drivers of groundwater sustainability and irrigated agriculture sustainability. We are going to develop models, data, that allow us to assess the sustainability of these two important things. And I've listed a whole range of climate change adaptation strategies. And once we build all those things, then we can start to do system-level analysis over periods of time ranging from now, 2022 to 2100 at a range of spatial scales. Okay? I've run out of time, but I would like to acknowledge our project managers. Hel Hoffman, who actually left Russia to return to Israel with her family. She helped the project get started, but we recently hired a new manager, Felix Ogan-Macon, who hit the road running. And thank you. I hope that gives you a brief overview about the project.